Riemann. Riemann's sum. So we're done with indefinite integrals. So we're going to start definite integrals.
Definitely.
So we briefly went through this kind of discussion before, but I'm going to do it again. So if this is seconds and this is meters per second, and I want to know how far I traveled, I guess I should start with a simpler one. Bless you. So let's look at the bottom one first. I'll give you a second to write it. We're going to write both, but we're just looking at the bottom one. I'm confused because, but I figured it out. Casey wasn't here, and it was like her desk vanished because she wasn't here. But really, it's just cold. Yes. But it looked weird when I was like, it's like that whole space just. Okay. Yeah, they just vanished. Okay, so in this bottom one, 20 miles an hour for 4 hours. How many miles did that car or person or whatever travel? 80 miles. So what you're doing there is finding the area, right? Like, what's the area of this rectangle? 80. So if you travel 20 miles an hour for 4 hours, you're doing 20 times 4, and you're finding base times height, and you find the area of the rectangle. So to go from miles per hour to miles, or meters per second to meter, or feet per second to feet, whatever, you want to find the area. So our job is going to be to find the area. So I'm going to look at this one now. And it's just not as friendly of a shape, right? So I can't just, there's no like formula for the area of a, whatever that is. So, we talked about this before, but what can I do to make it to help myself, to estimate the area?
Break it up.
So I could break it into rectangles, right? So let's say I'm going to use those 3 spots to break it up into 4 rectangles. There are 4 ways you have to know how to do this. And we'll do notes on them all. I'm just kind of talking up here. Don't worry about writing. Really, just listen to what I'm saying. So the question is, okay, here's the base of this rectangle, right? What am I going to use for the height of that rectangle? There are 4 methods. One says you use the left hand's x value in that interval. You go up till you hit the graph, and you pretend that left hand height is the height the entire way across. So if I'm doing that here, am I underestimating or overestimating? I'm underestimating, right? Why? What is true about the function overall that makes it so I'm underestimating when I look at the left-hand endpoints? Increasing. If this were decreasing, wouldn't the left-hand endpoints be higher? Does that make sense? All right, so that's one method. That's called LRAM, left rectangular approximation method, where you take you got your, like this might be 0 and 1, you pretend 0 is the height, or the y value based on 0 is the height the whole time. There's also RRAM, which is the right-hand approximation method. So then you got this interval, you look at the right-hand endpoint, and you go back, and you pretend that's the height for the entire interval. Overestimate or underestimate? Overestimate because it's increasing. What if it were decreasing? The right hand would then be an underestimate, right? So if it were decreasing and I'm doing the right-hand endpoint, I'm always taking like the lower value in that spot. All right, let's do it. That's left and right. There's also midpoint, which then you would go to like the middle of the interval, go up until you hit the graph, and pretend that's the height the entire time. So that could be over or under. It just depends on like kind of how it's curving. Does that make sense what it is? You go into the middle. And then there's a trapezoid rule, which says you make all of those trapezoids. So you go up on the right, you go up on the left, and then you connect those. So that one's kind of just a rectangle. You see how that's making a bunch of trapezoids? That one's kind of nice because you don't ever really have to use trapezoids. It's just you find the left and you find the right and you average the other. So that there's not really four, there's just three that you can combine into four. So we're just trying to estimate the area. And when we learn it, when we do the integrals, that's going to give us the exact area. But they do test the this is kind of like when we did limits with all the H stuff. And it was a big pain, and then I was like, oh, here's a shortcut. This is like the long pain way. And then I'll show you. You kind of know the shortcut already, but I got to show you a different shortcut. Okay, so let's do an example. Let's say y equals x squared from 1 to 5. These are x values? What's up, Fred? What's the question? I don't get to know the question. Okay.
I asked you what a trapezoid was. I didn't think I'd bother you.
Well, like my point is, if you have a question, maybe others do also. That's where I was kind of headed with that.
I just figured that was me with no knowledge of pennies.
A trapezoid is it's four sides. I think the only requirement is that two lines are parallel, and then once you have two lines parallel, it can be whatever you want. So, like, that's actually a trapezoid. It's just a special kind of trapezoid. It's called a rectangle. Trapezoid is just two parallel lines. Does that help?
Yeah.
Okay. So, then I'm going to say LRAM 4. Is the way they would write this.
Why 4?
What?
Why 4?
Funny you should ask that. Just about to explain that.
Oh.
So this is the interval that we're looking. So y equals x squared. I can graph this one. I mean, that's pretty easy. So I'm looking like from there to there. So I'm looking for this area. The 4 tells me how many rectangles I'm supposed to use. So I've got a length of 4. I've got to make 4 rectangles. So how big should each rectangle be? What's the base of each rectangle? I've got a distance here of 4, right? 4 length divided by 4 intervals equals 1 interval. 1 for the interval length.
Alright.
Does anybody need me to go through that 4 divided by 4 calculation again? Or are we good? Probably didn't need to write that down, but that's okay. Okay, so I'm going to start by making a table. Plug all of those x values into the equation and put the y values in that table. Maybe just square it. It was pretty easy. Although I did have to go over 4 divided by 4 and what a trapezoid is. So we might need all squaring things too. I'm not sure. We'll see.
I didn't know what it was.
Yeah.
They don't
I didn't
actually
take
go
geometry and I knew what it was. So.
How many weren't quite clear on what a trapezoid was? I think it's a fair.
A Okay, just do it.
I didn't
Yeah,
know
no, they're just the way to be honest.
No, what I
If
do
your description was bad, I question.
Like I, okay, like
You
you
kind of
the way it is.
I just forget what a like a
Okay,
four
that's
like
alright.
four sided object is.
And we've lost control. Alright,
Okay, sorry.
reel it back in. Hey! You're fighting about shapes back there?
Yeah, he's arguing why trapezoids have to have 6 lengths and size.
They do not.
See, more than him, more than me.
I know.
Yeah.
So this could be a trapezoid.
This is
Pile, I drew a trapezoid for you.
rectangles are also.
Yes. Okay.
Yes.
Now,
Okay.
LRAM 4. With all that information. I am just finding the area of 4 rectangles. What's the area of any rectangle? I hope we know this one. Based on sight. Awesome. We're kicking geometry's ass now. Okay. This first rectangle is from 1 to 2. What is the base of that rectangle? So I'm going to write out based on side plus based on side plus based on side plus based on side, just to make myself feel better. So the base of the first rectangle is 1. Keep in mind now, for the height, this is where it matters. If I do LRAM, it's different than if I do RRAM, than if I do midpoint, than if I do track. So this is where the difference is. For LRAM, I'm using the height based on the left hand. My 2 endpoints here are 1 and 2. I'm going to use the height based on the left-hand endpoint, which is 1. So what is the height of this graph when x equals 1? 1. So what I basically just did, if you're looking at the table, the distance between those 2 points is my base, and I take the left-hand value, and that becomes my height. Keep going. Between 2 and 3, what's the base of that rectangle? Also 1. And the height will be based on the left-hand endpoint. So you're going to use the 2. So plug 2 in, and what do you get? 4. So here, the distance between 2 and 3 was 2, and then I used the left-hand endpoint to get a height of 4. What number in this table will never be used? 25. In this problem, we'll never use the 25 because that'll never be on the left-hand side of any of our rectangles. 3 to 4, again, the base is 1, and I use the left-hand endpoint to determine the height. What's the height when x equals 3? What's the part where you tell me? 9. Like, I just need to know if you get it or not. Did you know it was 9?
Yeah.
Okay. Plus, and then from 4 to 5, base is still 1. You'll find the base is pretty common as we go. And then you use the left-hand number, so you're using 4 as your height. Or you're using 4 to find the height. So what's the height when x equals 4? 16. So if you add all those up, you get 30, right? Let's do RRAM of 4. I'm going to do that in a separate drawing, separate calculation. You always look at the 2 endpoints, and L, you take the left-hand endpoint, R, you take the right-hand endpoint. Is that what you're saying? So I've still got my chart. I'm just rewriting it so I can draw it again. Blush. Alright, so if I were going to do RRAM of 4, again, it's based on side, plus based on side, plus based on side, plus based on side. So my first interval is from 1 to 2. Okay? That's the base is how big? The base is 0. The only reason is because when I started the problem, I said we're going from 1 to 5. You don't just get to pick whatever you want.
No.
I decide what's going on. So from 1 to 2, what's the base? 1. What x value determines the height? What X value determines the height? 2, and what is that height? 4. And then, so if I'm drawing it now, I go from 2, I go up, and I pretend that's the height the whole time. So now we're overestimating, right? From 2 to 3, what's the base? 1. What X value determines the height? 3. And what is that height? 9. So which value in this table in this problem never gets used? 1. This 1, right? Because that'll never be on the right-hand side of anything. So then it'd be 1 times, what's next? 16, and then 1 times 25. So that comes out to... Yeah, 54. Yeah. So if I drew those, it would look like this. So you just want me to say drew. Does that help? Trap. I understand you do. Wait until I'm damn good ready for your question, sir. Trap is LRAM and RRAM averaged together, so it's not like a whole new calculation. You would just go 30 plus 54 over 2 is 42. So that's like, if they just ask for trap, it's kind of a pain because you have to do 2 calculations to get to it. But if they ask for all 3, it's like, oh, I already did that. Are there any questions? You seriously are not going to ask a question?
Just a second, I gotta finish reading.
Is the trap theoretically obvious or the most accurate? Because you take the overestimation.
So it depends on the curve, but in general, it's more accurate than L and R because it's like a blend of them.
Right.
So you're canceling out errors, kind of.
That's what I figured.
Yeah. And MRAM is pretty good too, which we'll see in a second. Any questions? Anybody? Anybody? No, what do you want?
We ever have to like add or subtract the little triangles with curved hypotenuse?
Everybody else know what he's talking about?
I think so.
Yeah,
The extra triangles.
So yeah, the extra triangles at the end.
We
They're
ever
not quite
have to
triangles.
figure out how to get rid of those in our final
They're not
answer.
triangles.
These?
They're almost triangles. Yeah. They're like triangles with curved hypotenuses.
So that's like the error part, right?
Yeah.
No, we don't have to figure that out.
Because the curved hypotenuse scares me.
It scares me too. Okay. Only one we haven't done is MRAM. This is the pain. This is the hard one. So trap is averaging the LRAM and the RRAM, and if we drew that, that's where you... Here, I'll draw a trap. Which 4?
It's
I gave that in the problem. I have to tell you how many rectangles you're going to use.
Oh, that's not our case.
So a trap would look like this. You'd go up on the left-hand side, up on the right-hand side, and connect them with a line. So this is certainly a better estimate than LRAM or RRAM, right?
Yeah.
Because you're kind of like LRAM's and underestimate, RRAM's over, and they're kind of canceling out a little bit in this one. MRAM is the pain. So I've got this base times height 4 times. My first interval is still from 1 to 2. What is that? How big is that base? What's the space from 1 to 2? 1. Now, to determine the height, you're not using the left-hand endpoint, you're not using the right-hand endpoint, you're using the midpoint. So the x value that determines the height of this rectangle is 1.5. What y value does that give us? Basically, you can just go 1.5 squared, which is, 2.25. Plus, so then I'm going like from the middle, and that's my height each time. Plus, my next base would be 1. What x value would determine my next height? 2.5. What do I do with that 2.5 to determine the actual height? plug it in, which is just squaring it. So 2.5 squared plus so the next rectangle is from 3 to 4. That base is 1. The height is going to be determined by 3.5. So I plug 3.5 into the equation, which is 3.5 squared. Do you see what I'm doing?
Yeah.
You guys with me? And then from 4 to 5, your base is 1, and your height is determined by the 4.5. Everybody have that answer already figured? 41. Everybody verify that? All right, we got 41. So here, you guys don't know how to do this yet, but you can watch and see if you can figure it out quickly.
I can't even see how.
That's too bad.
Yeah, you're right. You were wrong on that screen.
The actual answer is 41 1/3. So, I mean, the trap and the MRM are clearly the closest in this case, and the LRM and the RM are pretty inaccurate, but still know how to do them. Questions on anything I just did? I'm not going to explain the extra part. Do I want you to write down what?
What you just did.
The extra part?
Yeah.
No.
Can you actually see the extra things?
No. You will see the extra part when I'm good and ready for you to see the extra part.
You're like, I'm not gonna show it to you.
Yeah.
Right. I just want to know it. Okay.
I'm trying to build suspense into my class, so a cliffhanger. So you tune in for the next season.
Right. But instead, it's more of you're excited students. When I'm ready.
My style might not be ideal.
Honestly, why do you have strip review?
Just
Oh my gosh. This is
not
recording.
okay. Not with the recording. Tune in next time for the answer to the problem.
Right.
Recording.
So we're really preparing for a holiday we know it's all great.
What I want you to do is basically the exact same thing I just did, where you're going to find all 4 of those, and you're going to draw all 4 of those also. So I want you, for LRAM 4, I want to see the drawing. I want to see the rectangles. X cubed is the parabola, but the negative side flips down. So it's like that guy?
So that doesn't even matter.
It's the whoosh. That's x to the third. So x to the third and x squared look pretty darn similar in the first quadrant. But now we are starting at 0. I didn't want Eamon to get mad at me, so I had to. No. Shut up, Pyle. I had said no. You continued to ask. Like my 3-year-old. She would actually. Oh, she's a jerk. If I tell her no, she'll start throwing things at me and stuff. That's awesome.
Were you like that as a kid?
I'm kidding.
Oh, no.
I was joking.
Do you guys understand what I'm asking you to do? So I'm just drawing it out, but you guys should be doing this too. And I'm trying to force you to practice all 4 methods and draw them so you understand what they're finding. So in the first problem I did, the one we just did all together, I made that table right away. That I think is helpful because I think it's nice to just refer to that table, but you don't have to. So if if I were doing this problem, so I can't show everything all at once. But at the top, I would probably go like this and just start putting in the numbers so that I have a quick reference for what they all are. It doesn't help with the midpoint one, but it helps with the rest. Do you guys have written down what you need to have written down? I'm going to look for something. Your calculators do these, but you need a program installed, and I don't have it installed on your calculator, so I'm going to try to find one on mine. I'm not. I'm just going to show you. No, you can just look at it and enjoy it and learn.
Right.
I'm getting fired. I'm on fire.
It's like you decreased your sample size. Standard deviation is higher than normal.
I can't like pick my own function. So there is that big enough for you guys to see? The last problem we did was from 1 to 5, right? This is, never mind. Try trusty Desmos. So this is what your drawing should look like for LRAM. For LRAM 4. I mean, just the general idea. The hardest part is probably your first rectangle should not exist. Because your first rectangle has a height of 0, right? And then you got these 3 that just get bigger and bigger. So there's the right-hand sum. I mean, it's hard to tell exactly, but it gives you some idea, hopefully. The left-hand sum would be 36. Just adding up, basically, right hand would be 100. It's a great question. Tune in next week. That's like my building the suspense.
Can't wait for next season.
This is the midpoint one. I can't show trap on this for whatever reason, but I'm just trying to help you get an idea what they look like, just to solve it. A little.
Yeah.
At least it's not making it dumb. I'll solve for that. should be 36. The right hand should be 100. Trap would be the average of those, which is 68. You guys have midpoint done or not yet? So no. So get your numbers. Oh. You can't do like 2.5 cubed in your head?
No, I'm sorry.
How many got the LRAM and the RRAM numbers correct? And trap that should
I don't
be
know.
correct. 36, 100, and then 68. One were you done with the midpoint one yet? Backfire. What? Yeah. The midpoint one should be 62. So you check that one here. Any questions I can go through, answer, re-explain? How many are done with the midpoint one already? You did get 62. How many are still working with it? This is your homework. There's like 4 of each. 4 LRAMs, 4 RRAMs, 4 MRAMs, 4 TRAPs. 4 problems where it says find LRAM. 4 problems where it says I think I started off by saying this. Yes. I grind.
Really, we're trying to answer what trap was.
The first 4 problems are LRAM. Next 4 I think are RRAM. Then was trap next. And then MRAM. Trap RAM. So I had the order wrong. Might freak people out. First 4 are LRAM. What are the next 4? The next 4 are midpoint. The next 4 are right. The last 4 are trap. You did it. It's just a thought. I'm just throwing it out as another alternative. You can read the instructions. I mean, it does say the words.
So will this be at the game?
Yes. We are